All right, so this is the last section. Again, like I said, I've started talking. Thank you. So, like I said earlier before I started recording, this will probably take more than just one day on this. So we'll probably push the test a little bit. I don't know. We'll figure out next week when we're going to have the test. I'm not really sure. Maybe Thursday of next week would be my guess. Just a guess. All right, let's do this. Let's grab, since it's coordinate geometry, and you guys already said it's like points and lines and all that kind of stuff. Give me like a 2-word description of a point. When I have parentheses and a comma in between, what do I call that thing? Ordered pairs. That's what I'm looking for. Okay, that's what I'm looking for. Coordinate, or what did you just say? Ordered pair. Okay. All right. So let's move that right there. And what I'm going to do, I think this is in the book. It's in my notes anyway. So I'm going to draw a triangle. Okay, at specific points, and then we're going to find some stuff. All right, that's true about it. Remember we said earlier, finding slope, finding distance, and all that kind of stuff. So let's do that. Let's change this to color. I'll tell you what, I'm going to plot the points. Well, I'm going to just write the points out, and then we'll plot them. When I say plot a point, that just means put the point where it belongs. Okay, that's basically what it means. So A is at -7, -7, 1. How many points am I going to need in order to get a triangle? 7 points? I need 7 points to get a triangle? Do I? How many points to get a triangle? Are you just playing with me, or are you serious? How many points do you need to form a triangle? 3. 3. Okay. All right. So there we go. So what we're going to do, I gave you 3 points. What we're going to do is this. We're going to find the slope of all 3 sides of the triangle, and then we're also going to find the distance of all 3 sides of the triangle. So we're going to find 6 different things here. Okay. So let's plot it first. -7, 1. So let's count. 1, 2, 3, 4, 5, 6, 7, 1. Right there. So that's point A. Call that A. B is 1, -5. So you go over 1 and what? Up or down?
You said -5?
-5.
Oh, you go
down. 1, 2, 3, 4, 5. That's point what? B. And then point C is 7, 3. So 7 is here, and then 1, 2, 3, right there, and that's C. All right? Now, what can I draw with those points? A triangle, that's right. So I just connect them, right? So I'm going to go from here to here. I'm going to go from here to here, and then from there to there. All right, there you go. There's the triangle. What did I say we're going to do with this triangle? We're going to find a couple things. What are we going to find? I didn't say midpoint. Slope. We're going to find the slope first, okay? So let's find the slope of what? Of all 3 of them, all right? This is kind of good review for us, all right? And there's a reason why we would want to find the slope of certain things. We're not really going to talk about that right now. We're just going to review to find the slope. If you remember, this should come back to you. You may not have it memorized right now this second, but this should come back to you a little bit. I always said this. Somebody said earlier, the rise over the run, okay? And that's absolutely true. Slope is rise over run. But if I want to put some letters in here, I say the change in y, remember me saying that a lot? The change in y over what? The change in x. I shouldn't say this, but I don't know. It just popped in my head, so I'm going to say it. I watch math videos every once in a while, right, to learn how to teach certain things maybe a little bit better. This guy I watch, he's from Australia, and instead of saying over, because we always say this, like 1/2. I guess this is an Australian thing. I don't know. But they say on. They say change in y on change in x. I always thought that was kind of weird. But it's kind of true, isn't it? Because it's on top of it. Anyway, just thought I'd throw that out there. I guess if you... No, you can't, because I don't have any kind of Australian accent. I did, yeah. In fact, I have a video out somewhere. It's not online though. I need to put it online where you can. It's not. It's not movies back then. This is 1973 and 1974. So we didn't have video cameras. They did have movie cameras, and they actually had movie cameras with sound, but they were really expensive. So my dad did have a movie camera, so I do have some like film. It was actual film of us, but you couldn't hear us. But what we did, in order to like write my grandparents who were back in America, we would have cassette tapes. We had cassette tapes back then. We have a little recorder, put the cassette tape in, and when we talk, we had a little microphone to it, and then we talk. Hey, Grandma and Grandpa, we're having a great time here in Australia. This is what I did, blah, 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 right? And so we kept those. So we would send those to America, and our grandparents and cousins and friends and stuff would be able to hear us talking. And I definitely got an Australian accent very soon after I started living there. And so it's kind of cool that when we came back to America 2 years later, we got all those audio tapes, and we still have those audio tapes. But some of the audio tapes are broken, and I have to go through and fix them. But I did make a video years ago when I first got married. I took pictures that my dad took of us in Australia, and then I put the sound of us talking, right? I recorded, I used that recording, and I put it on there. And this was before the digital, before I did it on the computer. I did it all with a camcorder. So it's a little rough, but I should find that video somewhere. I got it somewhere. I don't know where it is exactly, but maybe I'll show you a little bit of it. But you can hear me talking, which is kind of cool. And I definitely have an Australian accent. I was 8 years old. Sound like a little girl, but but every 8-year-old boy sounds like a little girl, don't they? All right. So anyway, Amaya, quick.
Yeah.
Why did I go to Australia? My dad was a teacher, and he applied for this thing called a teaching fellowship. So at his school, I guess they sent some papers around and said, hey, if you want to go and teach in Australia, here's an application, apply, and we'll set you up with a job and all that kind of stuff. And so he was accepted. He was one of the few that were accepted to go over there and teach. And so we got to go over there. They had a job waiting for him. We had to find a house and all that kind of thing, and had to buy a car and all that stuff. And so we knew we were only going to be there for 2 years. But yeah, we went there just so my dad could teach. And so it was cool. It was a great experience. It was a fantastic experience. Best experience. Yeah, we lived in Delaware, lived in Newark. We actually rented our house out for the 2 years. So when we came back to the same house. So it worked out really nice. So yeah, that's why I have the Australia stuff back there. And I got a little Australia flag right here. Because, I'm not Australian. I lived there for a couple years, but it had a big impact on my life. All right, here we go. Let's do slope. So I knew I shouldn't have told that. As soon as I thought I was going to tell the story, I know it's going to go longer than what I anticipated, but that's okay. It was worth it. It's fine. So the slope is the change in y over, not on, but over the change in x. What does that mean, the change in? It means you subtract. So what do? I subtract the y's, put it on top, and then what? Subtract the x's and put it on the bottom. Right? That's the key right there. That's your formula for slope. It's actually fairly straightforward. All right, let's make this kind of colorful here. So what I'm going to do is find the slope. I'll put m, because remember m stands for the slope. It's kind of weird, but we use m for slope. And let's find our three sides. What side do you want to do first? Let's do AB. Is that all right? So I'm going to put a little AB right there. So what does that mean? M and then a little AB. It means the slope of what? Line segment AB. That's right. So let's do it. So here's A, here's B. Let's do our formula. What do I put on top? The y's. Okay, so I subtract the y's. It doesn't matter what order I subtract them, but I have to subtract them in the same order. So if I go 1 minus negative 5, I have to do what with the x's? Negative 7 minus 1. Everybody see that? So you do the x's first. What is it? 1 minus, it's not 1 minus 5, because what is that number? That's negative 5. So 1 minus negative 5 over, let's do the x's. The x's are the first ones. Negative 7 what? Minus 1. Let's do the math. 1 plus 5 is 6 over, that's supposed to be an equals. Negative 7 minus 1. Can you do that in your head? Add the opposite. Now what is it? Negative 8. Let's always simplify it. So what does that become? 3 over negative 4, or just negative 3/4. Doesn't matter where you have the negative. Could be on the top, could be in the middle. Could be on the bottom. So that's the slope of AB. All right. Let's do the rest of them a little bit faster. So what's another side? Let's go BC. So the slope of BC. So it's BC are these two right here. So rise over run. So the rise is -3 or -5 minus 3. Or the change in y. That's how math teachers usually say it when they talk about slopes. So I want you to get used to hearing it that way, all right? So it's the change in y over the change in x. Change in something means you subtract them, right, from one to another. If you're 15 years old and you were 12 years old, what's the change in your age? It's 3 years. What'd you do? What math did you do? You subtracted, correct? So that's why it's the change in. So it's -5 minus 3. What's the x going to be? 1 what? -7. Good. Right? Do the math. What's that? -8 over what? -6. Negative over negative is positive. Let's reduce. 2 goes into that 4 times. 2 goes into that 3 times. So that's the slope of BC. Now, back when we learned about slope, do you remember if two lines were parallel to each other, what was true about their slopes when they were parallel to each other? They were not the same line, but they were the same slope. They were the same slope. No, because it's negative over negative. This is -8 over -6. Negative over negative is positive. Okay? Good question, though. Do you remember when you had parallel lines? What was true? I'm going to copy and paste. Oh, why did it go way down there? What's true about the slopes of those two lines if they're parallel to each other? They are what? They're equal. They're the same. Okay? They have the same exact slope. What did we say was true about two lines that are perpendicular? Oops, I don't want that. Forget that. Remember what we said was true about the slopes? They were negative reciprocals. Do you remember that phrase? We used that quite a bit back then, didn't we? They're negative reciprocals of each other. Take a look at these two slopes. This is -3/4. This is +4/3. What's true about those two slopes? They're negative what? Reciprocals of each other, right? That one's negative, this one's positive. This one's 3/4, this one's what? Flipped it, right? 4/3. They're negative reciprocals. So what do you think might be true about AB and BC then? They are, what did we say? Oops. What did I just do right here? Oh, I know why I did that. Sorry, I got to change my pen settings again because I touched that thing right there. All right, so what's true about, why is it doing that? Oh, maybe because I didn't change it. There we go, now it'll work. Let's try it one more time. There we go, it works. All right, so look, they're perpendicular. So what's true about AB and BC then? They are perpendicular. Why? Because the slopes are negative inverses of each other, or negative reciprocals of each other. Inverse reciprocal, you can use the word interchangeably. So I think that's pretty important. So what kind of triangle is this? Come on, everybody knows that. It's a right triangle. Yeah, it's a right triangle, all right? Sometimes that's very important, all right? So I just saw this. I don't know if they did that on purpose. They probably did, all right? But I saw that they were negative reciprocals of each other, so the first thing that popped in my head was, hey, those two line segments, they're perpendicular to each other. So that means that's a right angle. That means that's a right triangle. Just from knowing about the slopes. Okay? Just by knowing that these two slopes are negative reciprocals, I can tell you that that's a right triangle. I might have been able to guess it before. I might have said, well, it looks like it. But now I definitely know that this is a right triangle. Okay? Now the third side really doesn't have anything to do with that, but let's do it anyway, just for practice. What's the third side? We'll call it AC. Let's do the slope again. You should be able to do this. A and C, we're doing these two right there. So we subtract which ones? The X's or the Y's first? The Y's, and we put them on top. So what are my numbers? 1, what? -3. 1 minus 3. And then I subtract the X's from each other, from A and C. So it's -7 minus 7. We figure out what this is. 1 minus 3 is -2. -7 minus 7 is -14. I know I'm going kind of fast, but this is not what we're here to learn. Negative divided by negative is positive. 2 goes into 2 what? Once. 2 goes into 14, 7. So that's the slope of AC. It's 1 over 7. If you take a look at it, check this out. We can actually look at it on the graph and see what it is. Look, if I went from this point to this point right here, how do I get to it? I go up 1 and I rise and I run how far? 7 over. Okay, there's 1 over 7. Agreed? All right, so it's kind of cool to see the math actually works out to the graph. All right, you could do the same thing from B to C. Go to B to C. Watch. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. There's 6 positive, 8 positive. You reduce it, it's what? It's rise over run. I'm sorry, I don't know why I went that way. Rise, which would be 8, and then run, which would be 6. So it's what? 4 over 3. Yep, just like this is. Okay, what's this slope? Well, this would be negative 6 down this way, and it would be positive 8 that way. So that's a negative 3/4. 6 over 8 is 3/4. Everybody getting it? Okay, enough of that. I think I beat this horse to death. All right, let's do, just so that I have some room here, I'm just going to erase all this right there. Oh, what's that? Dismiss that. All right, and let's get rid of this. Let's get rid of this. Let's get rid of that blue line right there. All right, now what are we doing? We found the slopes. Now what are we going to do? What did we say? Do you remember? Find the distance. Okay? All right, let's find the lengths of these. All right, the distance. Now, we got to know the distance formula. Distance formula is a little bit more involved. It's a big square root, and then you've got a parentheses and a squared, parentheses and a squared, and you add those up. Do you remember what you put inside here? The x's and the y's. So the x, we'll just put the x first. So it's x1 minus x2. So we just subtract the x's, put them here. And then we subtract the y's and we put them here. It really, on slope, it absolutely mattered what order you subtracted. Okay? On this one, it doesn't make any difference which order you subtract. So this is how you do the distance. So let's do these kind of quick because we got some more stuff. I want to get to the next thing before we get out of here. So let's do a couple of these. I don't even know if I'll do all 3 or not. So let's do AB. Let's find the length of AB. All right. So watch. All right, here we go. That's a little squiggly square root, but that's okay. So first thing I do is I put the parentheses and the squared here. And now I got to subtract the x's from each other. So I'm doing AB, these two right here. So subtract the x's from each other. What do I get? Negative 7 minus 1. Now I subtract the y's from each other. And again, it doesn't matter what order you subtract them. It doesn't make any difference. I'm just going to go with the first one minus the second one. So it's going to be what? 1 minus negative 5. And now I just do the math. Okay, just set it up. If you can memorize the formula, distance formula, it really isn't that bad. So what's going to go in the first parentheses? What's negative 7 minus 1? We did this already for the slope. It's what? It's negative 8. Okay. Uh-oh. My goodness. Are you kidding me?
Are you guys crazy?
You're crazy, dude.
Put it up on my desk. Turn it off. Turn it off. Don't just put it on silent. Turn it off.
You need to turn it off on silent too, real quick.
You're cool.
Like, there been that money calling you.
Okay, here we go. 1 plus 5 is 6, right?
Okay, dude. Don't cry.
And squared. Let's do this. Everybody look. What's negative 8 squared? Well, the negative really doesn't make any difference because when you square a negative, everybody's listening, right? When you square a negative, what are you doing? It's negative times negative, right? Which is positive, right? So the negative really doesn't make any difference. So what's 8 squared? 64. What? 8 times 8. It's not 8 times 2. It's 8 times itself. That's a common mistake. People do that all the time, all right? It's 8 times 8, which is 64, plus 6 squared. Here's a chance to redeem yourself, Cabri. What is it? 36, okay?
Avery, don't cry.
Now watch. This is the only one we're going to do because I want to get to the next topic, all right? 64 plus 36. Can anybody do that in your head?
You said what?
It's 100, all right? Because look, 4 and 6 is 10, right? Carry the 1, yeah, right? 6 and 3 is 9, plus that 1, it's 10. Boom, there you go. What's the square root of 100 in your head? It's 10. It's not 50. We're not taking half of it. We are not taking half of it. We are asking ourselves, listen, hopefully, if you listen to me, you might learn something. So, the square root of something means what number times itself. It doesn't mean half of it. It means what number times itself. The same two numbers multiplied together equal 100. What same two numbers multiply together to be 100? 10, not 20. 20 times 20 is not 100, right? But 10 times 10 is 100. So what's the square root of 100? It's 10. So what did we just find? We found the distance of AB. So what's the length of this? It's 10. Now, I'm not going to do the rest of the work. You can do it if you want to. But BC is going to be the same exact thing. That's going to be 10. And then when you do the AC, it actually comes out kind of weird. It's the square root of 200, which I'm not going to talk about this today. This is an algebra topic. Actually, let's do this. But 100 times 2, the square root of 100 is 10 times the square root of 2. Don't worry about that. I'm not going to make you simplify the square roots, okay? If this was an Algebra 2 class, you'll take Algebra 2 next year and you'll do square roots. You're going to have to simplify it. You're going to have to change it from that to that. I'm not teaching it now because I'm trying to teach geometry right now, okay? So anyway, that would be the length. So what kind of triangle is that thing? It's a right triangle, and you got two equal sides. So if they've got two equal sides, what kind of a triangle is it? A triangle with two equal sides is what? Isosceles. Equilateral means all three are equal. Okay, these are not all equal to each other, but it is an isosceles right triangle. All right, just from this, look, just from this information right there, I did some work on this, and I could figure out that this was an isosceles right triangle just from that information. That's coordinate geometry. Okay. And coordinate geometry is very, very useful in the math fields. Scaling is no sides are equal to each other. Isosceles, two sides, equilateral, what? All three. Okay, enough of that. Let's do this. Now we're not going to do, coordinate geometry. Now we're going to do this. I'm going to just draw a triangle. It doesn't have to be any kind of a special triangle or anything like that. I'm just going to make it look like it looks in my notes, all right? And this probably is the way it looks in the book. It could be any triangle, doesn't matter. Now, watch what I'm going to do. Everybody watching? With my program, if I select it, I don't know, it's hard to see. Maybe if you're up close, you can see it. There's a little dot right there. Where do you think that dot probably is? At the midpoint, exactly right. So I'm going to put a little dot where the dot was on the program. Right? I select that side right there. There's a dot right there. Where do you think that is? Whoops. That's a midpoint.
So it's that little dot in the middle.
That little dot right there was a mistake. Boom. Now it's gone. Okay? So look.
Okay.
Everybody watch. We don't have much time, so let's pay attention. You got to know how to do this. So this is a midpoint of this side. Agreed? This is a midpoint of this side. So if I connected the two midpoints, yep. If I connected the two midpoints, now I said they're midpoints, so that means that this and this are equal, correct? If this is halfway in between, those two parts are equal, and what else? This little bit right here and this little bit right here are equal to each other. This red line, not red lion, but red line right here has a name. It's called the mid-segment. Kind of makes sense because it connects the what? The mid-points. The midpoints, okay. So it connects the midpoints. And it's a segment. It starts here and it stops here, so it's a segment. We call it the mid-segment. Well, what's cool about this is not just the name of it, but there's two things that are true about this. Let's do a different color. There's two things that are true about that mid-segment. So, number one, the first thing that's true is the mid-segment is parallel to the third side. What do I mean by the third side? The third side that I don't have connected. You see it? See, this connects this side and this side. Which side is not connected? This one, and we call that the third side. Okay? So this mid-segment is parallel. Let's put some letters in here. A, B, C. We'll call it X and Y. Is that right? be a little different. So XY, line segment XY, is parallel to what? Line segment, look at it, BC. You got it. That's the first thing we know, that the midsegment is parallel to the third side. We'll put a little arrow. What does that little arrow mean? Does it mean they're equal to each other in length?
No.
It's definitely not equal to each other in length. It means they're parallel to each other. Exactly. Okay. All right. Everybody got that? And
That's the function parallel?
yes. Yeah. The two up and down ones. I've shown you that before, haven't I?
Nope.
I bet you I did.
You did, bro.
I'm like,
Okay, we did that before, right?
no,
Gotcha.
cut.
Bro, hold on, I'm just about to see you real quick, bro.
All right. Here's one more thing. Okay. Actually, let me think about this. I thought there was two things
Look, bro, my
that were
mom-
true about this.
Yeah, on the top. Something.
Yeah, that's true.
What's that mean, sir?
It means it's like one of them.
All right, I think I did this right. Okay, watch. Here's the second thing that's
You
true.
need to stop laughing your phone off.
Here's the second thing that's true. All right, that the length of XY, so I'm not going to put a line segment over top of it. When I don't put a line segment over top of it, that means the length of that line segment, okay? The length of the line segment is actually half of the length of the line segment of that third side of BC. What does that mean? That means, what if BC was 12? What if BC was 12? What is XY equal to? It's equal to 6, okay? What if I went the other way around? What if I said that XY was 3? What would BC be equal to? That would be 6. I should have picked a different number than having 6. Let's say this is 7. What's that? If that's 7, what's BC? It's 14. Everybody see that? Okay. Let's do this just to kind of show you. Hopefully this works. So if I copy this and paste it, watch this, and I move it to here. Let's make it a different color. Okay, now watch. And I paste it again, make that a different color just so it looks a little different. And then, whoops. Come on. There we go. Look at that. Do you believe me? Yeah, it's pretty close. This was pushed over a little bit. But look at those two right there. That green one and that blue one were the same length of that red one. So it took 2 of those to make up that whole thing. So would you agree with me that this is, if this is 7, then this is what? 14. All right? So those are the things that we know about the mid segment. It's a nice little thing to have. We'll do a little bit more with this, Monday? Today's Friday. Thank goodness it's Friday, right? All right, so there you go. So I will, I'll be nice to you and no homework just because we haven't finished the lesson yet, okay? So no homework for the weekend. Enjoy it. Go to church Sunday and have a good weekend.